if you put something that has water in it, and of course our bodies are mostly water, a frog's body is mostly water, you can put that in a magnetic field gradient. So it's a strong field here, it's a weaker field there, it's the weakest field up here. And that water-containing object is going to want to drift up to the weaker magnetic fields. So by configuring your experiment right, you can get that frog to levitate. You, in principle, can get a human being to levitate because we contain so much water.
Could this be the way they get the saucer to levitate? Is the ship made of some diamagnetic material?
In principle, magnetic fields could be used to propel a ship through the air. And it's natural enough that when we look at the story of unidentified flying objects to think about magnetic fields. The levitation experiment with the frog works because there's a big magnet that's positioned right beneath the frog. And that's how we can make the magnetic force be equal to and opposite the gravitational force. If UFOs were using magnetic levitation, we would not only notice the UFO, we would notice the big magnet that they're lugging around underneath the flying saucer. So I don't think that would be what they would be using.
The alien ship doesn't hover over a big magnet. However, the Earth itself generates a magnetic field. That's why compass needles point north. Maybe the alien ship uses the natural magnetic field of the Earth for propulsion within our atmosphere. But the Earth's magnetic field is very weak. We are a few Nobel Prizes away from levitating a ship using a force field generator. But remember, either an electromagnetic repulsive force field generator or an anti-gravity drive could meet the challenges of gravity the aliens face. And the anti-gravity drive is what this alien ship has under the bonnet after all. The alien anti-gravity drive manipulates Earth's gravity, reversing it against itself and focusing it to prop up the ship on a gravity wave. It can go in any direction it wants. This exotic form of space travel is necessary when crossing galaxies, because conventional rocket power just isn't enough. Space is just too big. Way too big.
Take a look at our solar system. If our solar system were about, let's say, a foot long, here's the sun and here's the orbit of Pluto, and you were to ask, well, where are the nearby stars? The nearby stars would be miles away.
After our sun, the closest star is in the Alpha Centauri star system, more than 4 light-years away. That means that even if the alien ship could travel at light speed, a mind-boggling 186,000 miles per second, it would still take over 4 years to get to Alpha Centauri from here. And even if we got there wouldn't be a greeting party. Scientists optimistically estimate the nearest habitable planet to be 45 light-years away. Clearly, the ship was using unconventional methods. Besides, covering such vast distances would require a lot of rocket fuel. All that fuel adds weight, of course. Consider how long it would take the aliens if they were using conventional rockets. Our Voyager missions that explored Jupiter and Saturn are the fastest man-made objects, traveling 10 miles per second. Pretty fast, but that's still not fast enough.
If the ancient Greeks at the time of Homer had launched a space mission to the nearest stars, and it traveled as fast as Voyager, the fastest space probe that humans have ever launched, and if they launched it 5,000 years ago, it would still be another 70,000 years before it would get to the nearest star. It wouldn't even be 1% of the way there.
The ship is designed to travel at the speed of light or even faster, which isn't possible using conventional methods. To do that, the aliens would have to break some laws of physics, because Albert Einstein won't allow them to go that fast the old-fashioned way. In the early 20th century, Einstein devised a radical new way of understanding the universe with his special and general theories of relativity. Einstein theorized that time is relative throughout space. It's gooey and flexible. One of the strange side effects of traveling close to the speed of light is something known as time dilation.
According to Einstein, the closer you get to the speed of light, the more the clocks on your ship slow down. So time to you passes more slowly. So if you have somebody approaching the speed of light, say 80 or 90% of the speed of light, time for them is passing very, very slowly.
If a rocket blasted off from Earth on a round-trip mission to Alpha Centauri, traveling close to the speed of light, years would pass here on Earth before the mission's return. But on the spaceship, only a few weeks would have elapsed. The crew would have aged only a few weeks, and the flight recorder would indicate a short journey.
It's not science fiction, it's really true. We can test this in undergraduate physics laboratories around the world every single day, and it works. It's really true that clocks do slow down relative to an observer watching someone as they travel near the speed of light. Now, this is, in principle, of course, great, but it's also a problem if some spacecraft does a return voyage and it takes 5 years for it to do, and 50,000 years later it arrives back at its home base.
But there is an even bigger problem. Our ship can only go so fast before it runs into Einstein, the ultimate galactic traffic cop. Einstein says there is a universal speed limit. It's not possible to travel faster than the speed of light, because at that speed, the laws of physics fundamentally alter mass.
As objects speed up to get closer and closer to the speed of light, they get more massive. If I take a single atom and I want to accelerate it to half the speed of light, using conventional rocket fuel, the amount of fuel required will be greater than the mass of the entire visible universe.
Our spacecraft, being made of atoms, would have the same problem. The closer the ship gets to the speed of light, the more massive it becomes, until ultimately, according to Einstein, it becomes infinitely massive. This is the mind-boggling relationship between energy and mass that Einstein grasped a century ago, and the rest of the world has been grappling with ever since. And you might think that such physics would prevent our aliens from traveling across galaxies. Clearly they're not, because our aliens have found a loophole in Einstein's general theory of relativity. Well, it's actually not so much a loophole as a wormhole. There may be a detour around the speed of light. The team is busy analyzing the exterior of our alien ship, even as we struggle with its gears and inner workings. And our technicians have made a major discovery. They've tapped into what we would call the ship's computer guidance system. It appears there's a map of the universe. This could be a real breakthrough. Contrary to what we learned at primary school, the shortest distance between 2 points isn't necessarily a straight line. To begin to understand what the aliens are doing, we again have to consult Einstein about his theories on gravity.
Einstein saw mass and space, matter and space, as connected in the sense that you could explain gravity by saying that mass distorts space, that it exerts some force on it. Space is curved in the vicinity of matter, and that the planets follow the shortest path on the curved surface of space.
So massive objects bend space itself. Proof of this bizarre theory, which secured Einstein's place among the gods of physics, was produced by two expeditionary British astronomers in 1919. The scientists took